names are Miyu Kokomi Maria and we're from Okinawa Christian School International. We'd like to introduce you to our Algae Air Purifier. Why algae? As the climate continues to deteriorate, with the main cause being greenhouse gas emissions, especially CO2, our concerns for our planet have led us to the question, what can naturally purify air and absorb carbon dioxide effectively? Many may suggest growing more terrestrial plants such as trees. However, it is a fact that planting more trees cannot prevent climate change. Therefore, we decided to take advantage of an alternative solution, algae, and by using their photosynthetic efficiency, we created this model to naturally, efficiently, and effectively purify the air inside your home as well. So, by how far does algae outperform terrestrial plants? One average-sized tree only absorbs, on average, 568 moles of CO2 per year. However, only 10 grams of algae is estimated to absorb an astonishing 411.72 moles of CO2 per year under ideal conditions. Therefore, just by algae model alone is equivalent to one tree on average. Our calculations for what we explained. Photosynthetic efficiency can be defined as a measure of the ratio of the photosynthetic output to the input of light energy. Algae has high photosynthetic efficiency due to its wide range of internal pigments that harvest more solar energy. They also have more surface area for light absorption. Liquid trees use algae to absorb CO2, hence they are much more effective than trees. Liquid trees are estimated to demonstrate a photosynthesis-based carbon dioxide binding efficiency that is 10 to 50 times higher than trees.
As shown on the slide, liquid trees are quite large, as they are made to be installed in cities and public areas. So we decided to make something similar, but with the advantages that you can place them in your home. But why homes are in small spaces? This question leads us to our purpose. Our purpose behind this project is not only to combat climate change, but to do it in a way that is actually effective and realistic. Therefore, we thought that a realistic and effective approach to combating climate change was to use business and marketing so that consumers can contribute to help change our planet one by one. If each person has this algae CO2 scrubber in their home, it will be more effective than planting new forests that takes time and space. Before we explain the experiment, we want to briefly explain how our model works. The air that is produced from the air pump travels through the tube and into the air stone, which then the air is transferred into bubbles. The air bubbles produced by the air stone and air pump help the trapped air bubbles in the algae to rise to the surface and release the purified air out of the bottle that is loosely closed so that the air can escape. So these are the steps we took to build our model.
Our objective was to prove algae can effectively reduce CO2 levels in a closed environment and to showcase its potential as a natural CO2 scrubber. We hypothesized that if algae can absorb CO2 through photosynthesis, then placing algae in a loosely closed container with a CO2 source will result in a measurable reduction in CO2 concentration and a corresponding increase in pH. This is due to the fact that CO2 converts into carbonic acid when absorbed in water, which thus lowers the pH level of water. However, if algae is added to the water, the pH increases because algae absorbs the carbonic acid within the water. Our independent variable is algae. Our dependent variable is the pH of the water. Our control group is the tap water without algae. Our experimental group is the tap water with algae, and the constant variables are light and temperature. These are the materials we used. We positioned both containers under identical light and temperature conditions. The room we used to place the experimental units in had measurements of 118 cubic meters, with more than 120 students coming in and out of the room every day. We first calibrated the pH meter using standard pH solutions. Then we recorded the CO2 concentration on the data table. This is a graphical representation of our data. These are the pictures for each measurement. To attain the average, we took the mean of the 3 trials. Studies show that even a slight change in pH, as low as 0.3, corresponds to significant CO2 uptake. This is a graphical representation of the average. The pH of our control pretty much stayed the same. There was no marked difference between the initial and the final. These are the pictures for each measurement. As you can see, there is no marked difference.
If we were to mass produce this, we would sell it for an unaffordable price that would be much lower than CO2 scrubbers sold today, which is around 10 to 20,000 yen. But our model only costs around 1,500 yen. Additionally, we would add a solar panel to power the algae CO2 scrubber so as to refrain offsetting the carbon dioxide emissions. This algae scrubber is great for places where the levels of CO2 is quite high, such as classrooms, offices, and homes in urban areas where factories are prevalent. These are our works cited